Hi y'all, today I'm talking about combining like terms. This is purely for review for your upcoming tests. So if you look on your first page, you should see 2-1 combine like terms to solve equations. Now in order to do this, we need to put everything with the same variable together and everything without a variable together. So in this first equation, we have 5x plus 0.45x equals 49.5. Now, I've already drawn the squares for you, but what these squares indicate is that when what we're interested in is to have one term. One term on one side and another term on another. That's how we solve the equation. We want the variable on one and the numbers on the right. So by the end, we only want a left on this side of the equal sign. And on the right, we only want numbers. Now the first step is we're going to stop at every plus or minus sign. That will tell us what a term is. So we have 5x, or 5 times x. We get to a plus, so we immediately know we stop. That's our 5x is our first term. Now we go to our second term, 0.45x. Now we stop, not because of a plus or minus this time, but because of an equal sign. With that equal sign, we know this side is all alone. And now we look at the right side to see what's on the right side. So we have 49.05. Now you'll notice there's no variable next to it at all. There could be in a different problem, but in this problem there's no variable. So we put a triangle around it because we know these boxes won't plus or minus with that. The different shapes do not plus or minus together, period. Now they can multiply and divide together, but that's not what a term is. A term is separation by plus or minus. So we know this 5x, this 0.45x, and this 49.05 will not plus or minus if they don't have the same variable. Now we do notice on this side that 5x and 0.45x have the same variable. So we can just add them together. Now, notice what I just did. I added 5 plus 0.45. I didn't add the x's together, didn't I? I didn't say, okay, here's one x, now there's two x's, so I'm going to add 2 to that. I didn't do that at all. All I added was what's called the coefficients. And that's all I want you to add when you're combining like terms. Add the coefficients, not the variables. Now, they have to be the same variables to add, but still just add the coefficients. So we have 5.45x equals 49.05. Now you'll notice on this side, this man's all alone. There's no one for him to talk to at all. So he's not going to combine with anything. If he's by himself on the one side of the equal sign, he's good. He's Gucci. He doesn't want to do anything more. Now, we'll notice the 5.45x still isn't alone. There is a number and there is a variable, but we just want a variable. We don't want any number. This is where we talk about SADMAP. SADMAP is the opposite of PEMDAS, and it tells us what to do when solving for a variable. It takes us to fantasy land, a land that works opposite, a mirror land of what we're doing in regular math. Regular math is PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. SADMAP, however, starts with subtraction and addition. So the first thing we do, we look and see if there's anything to plus or minus. Well, we don't see a plus or minus, so no. We see if there's that's supposed to be division, not a P, is we see if there's a division or multiplication. Now, there is multiplication. If you have a coefficient in front of a variable, so a number in front of an x, you're automatically multiplying. But remember, this is mirror world. This is opposite land. So in opposite land, instead of multiplication, we divide. And once again, y'all, I want you to use your calculator. I don't want that long division. I could do that long division, but it'd take me 5 minutes. Grab a calculator, put it in, and you get 5. You get x equals 9. So we have just solved this problem. We have all the variables by itself on one side and all the numbers by itself on the other. So we know our value, our x, equals 9. So I want you to try 1, 2, 3, and 4 on the next page during this break. I want you to, especially on number 2, to make sure you use your calculator. It gets a lot harder if you don't. Now, if you don't want to, you can still do it, but I highly advise it. So pause the video here and try those problems. Alright, sorry for the brief aside. Solve equations with variables on both sides. So on the last problem, we had variables on one side and non-variables on the other. But that doesn't always have to be the case. Sometimes our variables can both be on the same side. Now when that is the case, on different sides. Now when that is the case, you still can solve. So we're looking at the example on 2-2. Solve 2x plus 21 equals 7x plus 6, 4x. That means whenever you see a 4 variable, that means it wants that letter by itself on the left side by the end. So that is the goal. Once we have that letter all by itself, we've done it. We're finished. We can't do anything more. So let's see. So the first thing we're going to do is we're going to find like terms. So we have a 2x. I'm going to stop because we got to a plus or minus. I'm going to draw a triangle around it. Doesn't matter what shape. I'm just showing my x's are triangles this time, unlike last time. See a plus. Then I get 21. But this 21 has no x. It has no variable. So I'm going to put a circle around it. Then we have equals 7x. So once again, at equal signs, we stop. Full stop. No, you cannot pass without doing mirror magic, mirror math. We get 7x. So we have another term because we got to another plus. We put a triangle around it. Then we get to the 6. We have a circle around it. So now we're going to solve our equation. We look on both sides and see that neither thing on both sides can combine. A triangle can't go with the circle. A triangle can't go with the circle. So now we want the circles on the right side and the triangles on the left side. Now, they might do this, they did switch it up on you, but notice the x remains at the bottom at the left. Honestly, you could go, as long as you're combining these correctly, you could have it on either side. But I like maintaining the x on the left side, even if I have to deal with negatives. So, the first thing I'm going to do is I'm going to get rid of my non-x's first. Now, you can get rid of your x's first, that's fine. But I think it will be more consistent if you try to get rid of your non-variables and lower degree numbers first. So I have a plus 21. Now remember, to get to the other side, think of this as a mirror where it's opposite. It's magic land. It's the opposite side. So opposite side of the mirror. Well, to cross into the mirror world, you need to do the opposite of that plus 21 because you want that plus 21 to go to its mirror world match, 6. But it has to be its opposite. Well, the opposite of a plus 21 is a minus 21. We put that minus 21 directly under its match. We do not want the circle to go with the triangle. The circle goes with the circle. And now using our calculators, because I know negatives can be hard, you need to do 6 minus 21. Now on this step, the variables do not change. They stay the exact same. So we have a 2x, that stays the same. Well, 21 minus 21 is 0. Whenever you have a plus 0, that means it cancels out. Because what's 5 plus 0? It's 5. What's 10 plus 0? It's 10. What's 2x plus 0? It's 2x. Anything added by 0 is just itself. Just like anything multiplied by 1 is just itself. So we have 2x. This goes away because it turns into 0. Equals the 7x stays the same. It's still my friendly triangle because it did not combine with the negative 21. We have 6 minus 21 is negative 15. Now, we have a 2x on this side and a 7x on this side. So now we want the triangles to go together. The circles are all happy together. They're fine. We have one circle. That's what we wanted. That's our goal. We want one triangle, one circle, one of each shape. But now we need to mash the triangles together. But once again, he's crossing the mirror world. So since he wants to join the x's on the other side, he needs to do the opposite of 7x. Now you might ask yourself, what's the opposite of 7x? What about negative 7x? Minuses and negatives are the same thing. So we can do negative 7x, which is just subtracting 7x, on both sides. And once again, 7x plus negative 7x, 0x. And anything times 0 is still 0, so you don't have to write it. And it goes away. So 2 minus 7x, use your calculators, negative 5x equals negative 15. Now this becomes just like our other problem. So just as easy as what we just did. We want to once again, we've been doing opposite PEMDAS ADMET. Notice how we did a subtraction first. We did subtraction first on both sides. So we had everything together. Now that we've done subtraction and addition, we want to do division and multiplication. So we have multiply by 5, but now we want our numbers to go with our other numbers. But this 5 as well has to go through the mirror world, has to go to the opposite side. So this is a multiply by negative 5. Now the mistake I see students make is they'll say, oh, that's a minus 5. I can just add 5. But we don't want that, because what will happen is that will turn this into 0. And then we'd have no x, because 0 times x is 0. It gets rid of the x. So instead, what we want to do is do the opposite, the mirror world, of negative 5. Multiply by negative 5. It's just divide by negative 5. And thus we are left, if you don't believe me, use your calculator, but remember 2 negatives make a positive with multiplication and division. We get x equals 3. And we're finished. That's how you solve problems with variables on both sides and constants on both sides. So now I want you to stop and try 1 through 4 on lesson 2-2. And I'll see y'all next time. Have a wonderful day.